Hello, everyone, and welcome to MOS Live. Today, we're talking with Museum of Science educators all about space. My name is Emily, my pronouns are she, her, and I'll be keeping an eye out for all of your questions today. Thank you for those of you who are tuning in on Facebook or YouTube, but please note that we are not able to share your comments with our educators from those platforms. For everyone here on Zoom, just press the Q&A button at the bottom of your screen to submit your questions. Don't forget to include your name and age if you'd like a shout out. If you'd like to see captions, you can click on the closed captions button at the bottom of your screen and select show captions. I would now like to invite my educators to come on screen, introduce themselves, and we'll get started.
Hi everyone, my name is Emily. My pronouns are she and her, and one of my favorite photographs of space is this one that I'll show you now. This is a photograph of the dwarf planet Pluto, and I love this picture because it's a reminder of how much we're still learning about space, even just within our very own solar system. So this photograph was taken 5 years ago when the spacecraft New Horizons finally reached Pluto. And before this picture was taken, this, can I go back? This was the best picture of Pluto that we had. And that doesn't even look like a planet or a dwarf planet. So we could barely learn anything from this picture. But once New Horizons actually made it to Pluto, we were able to see more of the features on this dwarf planet. We saw ice volcanoes erupting on its surface. And again, even today, we're still learning so much about space and even our neighborhood in space.
Hi everyone, my name is Janine. My pronouns are she and her. And one of my favorite photos of space comes from the Cassini mission. So I'm sharing you this one particular picture. These are Saturn's rings. And then you can see two of Saturn's moons. Saturn is now the king of moons and has the most moons of any planet in our solar system. But these are Titan is the big one in the background. It actually has its own atmosphere, and Epimetheus. But I really like it because, again, it kind of gives you perspective of our place in the universe and getting to see how these things are interacting with each other, because they're all moving around, and this is just like a moment in time that was captured. So I really like that.
I love both those images. Hi, everyone. My name is Meg. My pronouns are she and her. And one of my favorite photos of all time of space is this one, which is a famous photo taken in 1968 by the astronauts on the Apollo 8 mission. It's called Earthrise. And it's the first photo taken by a human of Earth from space. And it's really special to me because it really emphasizes that perspective that Janine just mentioned, that we can sort of go to space and look back on ourselves, and we can see all of humanity in this little spaceship Earth traveling through the void of space. And I think it really makes us feel more connected than ever. So this is one of my favorite photos from space of all time.
All right, wow, thank you all for sharing all of those. We have our first question here from Kara, age 11, asking, how have astronomers ever observed a violet shift like they have blue shifts and red shifts? Now, I don't even know what a shift is, so if you could explain that to me as well, that would be awesome.
Absolutely. So Kyra is talking about Doppler shifts. So if an easy way to think about that is if you've ever heard a fire truck coming towards you, and as it gets closer to you, you hear the sound of the siren increase, it goes higher in pitch. And as it leaves, it gets lower in pitch. That's because sounds are waves, and as they are shorter, you get a higher tone. And as they're longer, you get a lower tone. The same thing happens with light. So as waves stretch out, as light waves stretch out, they shift towards the red. Or as they get closer together, they shift towards the blue. So when you talk about a violet shift, things could shift towards violet, but we just talk about red or blue because that's like saying going far away or going closer to us. So it's telling us which direction the object is moving in. So if it's moving towards us, all those waves will all squish up together and the object will appear bluer than it should. And if it's going away from us, those light waves will stretch out and they will get longer, and so they will go redder than they should appear. But yeah, it's not necessarily that they appear red, it's just that they're shifted over towards the red side of the spectrum. I don't know if anybody else wants to say something about that.
Sounded good to me.
Thank you so much. Another one here from Zachary, age 7. Have any spacecraft traveled to the far side of the moon?
Yeah, that's a really good question, because that's a really exciting thing that just happened pretty recently, just earlier this year. There was a Chinese mission, Chang'e 4, that landed in February, and I believe of 2020, and deployed a rover to the far side of the moon. And that is the first time that I believe anybody has landed on the far side of the moon. And that's really neat because the far side is very different from the near side of the moon. And it's because it's far all the time, we actually don't get to see it from Earth. So the fact that we can have spacecraft venture out for us and sort of take a look around is really exciting. It might help us figure out what's going on with the far side of the moon. We study the near side quite a bit because we can see it from our own, backyards and with our telescopes from Earth, in addition to the spacecraft we send and the piloted missions that have been sent to the moon. So great question. Yeah, that's something that just recently happened.
And I think even as early as the Apollo missions, we definitely saw the far side of the moon because we had orbiters going around the moon. But like Meg said, that was the first time that we've landed something there, which is even more exciting than just seeing pictures of it.
Yeah, that's a great point.
Thank you. And we have a few questions about the moon, so I'm going to keep asking some moon questions here. Kira, age 6, wants to know why the moon is so cold and why the sun is so bright.
It's a cool question. So our moon is very different from our planet for a few reasons, but one of them that I'll point out is the fact that it doesn't have an atmosphere like we do. So because it doesn't have an atmosphere and because it has no way to sort of trap heat from the sun onto its surface, that's why the temperature on the moon is much lower than what we experience on this planet. Now, the moon is also a very light color. It has, we've all seen it in the sky, it's kind of white or gray in color. And that light color is very good at reflecting light. So that means that when sunlight is bouncing off of the moon, and because the moon looks so big in our sky, that means that it looks especially bright, especially when we see the full moon in our sky. So it can reflect sunlight really well because it's so bright in color, it's so light in color, and it also appears as that nice big disk. So we get a ton of light energy bouncing off of it and then into our eyes every time we see it.
Thank you. And then we had a question about how, from a hero, age 11, how long does a moon day last? And what time was it on the moon during that Earthrise photo?
That is a good question. I don't know offhand what time the astronauts felt that it was. It's kind of an interesting question because you'd have to look again, and maybe I'll share that photo again. If you look at which part of the Earth was being illuminated by the sun at the time it was taken, you might be able to tell where it was noon the time it was taken. Let's see. Yeah, let's look. But as far as, so I believe that's over the Horn of Africa a little bit here. So so you can see this bright spot that's on the Earth there. That's what is called the subsolar point. And that means that that is where on Earth the sun is directly overhead. And when the sun is directly overhead, that means it's noon at that point on Earth. So I don't know what time the astronauts were experiencing, but that's where the position of the Earth was at the time that they took this photo. It was on December 24th in 1968. The other part of your question, just really quick, or if somebody else wants to jump in, how long is a day on the moon? So the moon is tidally locked with the Earth, which is why we only see the near side and we don't see the far side. And what that means is that the moon rotates on its axis once every time that it revolves around the Earth. So those two numbers are the same. And so that means that it takes 1 month for the moon to go around us. That's why we think about moons being connected to our monthly calendar. So a day on the Earth is the same as that. It's 28 Earth days. If that makes sense. I probably said that in a very confusing way.
I think a good way to think about this is that the phases of the moon take an entire month to go through, and that's you watching the sun or go across the moon, right? So if it's completely dark on the side that we're facing, okay, that's us looking at midnight. And then as it waxes and becomes a full moon, right? That's it. Us looking at it at noon for the moon, for if we were standing at that point on the moon that we can see, and then all the way back again to new moon, right? So when it's black on our side again, or night on our side again, and that's one full day.
Yeah. Well said.
All right, thank you. Gwen asks, what are black holes made of?
Lots and lots of stuff. So black holes are basically an infinite amount of matter in an infinitely small point. And there's so much mass, so much matter in that single point that it pulls down on the fabric of space-time and creates gravity. Because it has mass, then the gravity of that is so great that nothing, not even light, can escape it. So just more stuff like stars and planets and all of that stuff, just really, 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 really small point.
Thank you. And Prisha, age 8, asks, why is the sun so big?
So in general, stars are very big. That's just kind of how they come. In order for a star to be a star, nuclear fusion has to be happening inside of it. And as long as that's happening, then it'll release a ton of energy, which is why we can see light coming from stars, and we can also feel heat coming from our sun. All that is happening because of that nuclear fusion in their core. And in order for that nuclear fusion to start, the star does have to get to a big enough size so that it has a strong enough force of gravity that starts to squeeze the molecules in its core together. So they're very big simply because that's what it takes to become a star. And our sun could fit 1 million of our planets inside of it. So our sun is much bigger than we are. And it's not the biggest star in space by any means. In fact, there are some stars out there that could fit billions of our suns inside of them. So stars are really big.
Wow, that's pretty crazy to think about. Faith, age 9, is asking, what is the brightest planet?
That's a good question. Oh, go ahead, please.
I think from Earth, the brightest one is Venus, because it's the closest to us and it has very, very thick atmosphere, has lots and lots of clouds. So that same thing that Emily was talking about earlier, where a lot of light bounces off the moon because of its color, a lot of light bounces off of Venus. And actually, because Venus is between Earth and the sun, we can see phases of Venus as well, which is very cool if you have a telescope. But don't go visiting Venus, because it's a horrible, horrible place for Venus to be.
I will also add that a close second brightest planet is Jupiter, because it's really big and it also has a ton of gas and clouds in its atmosphere. It's very easy to reflect light off of. So Jupiter is the second brightest planet, and it is visible in the nighttime sky along with Saturn. So you should definitely try to find that later on tonight or the next time you're looking up at the night sky this summer.
Yeah, and I'll give a plug. On Fridays, we do a virtual planetarium called the Sky Tonight. So if you're not sure what's up in the sky and you want to know, those are the people to ask, and they'll tell you all about it. And come join us on Fridays.
Thank you. Aisha asks, have scientists believed there have been any forms of life on any other planets or moons in our solar system in the past?
I'll take a stab at this one. So we still don't know whether there has been life on other planets in the solar system in the past, but that is something that scientists are really, really interested in finding. There are certain places in the solar system where we think that it could be likely that we will find evidence of past life. Mars is one of those places, and many missions so far, and including the Perseverance rover Mars 2020, is going to continue to look for signs of life on Mars. And there are lots of other places in the outer solar system as well that people are very excited about possibly finding traces of life outside of Earth, including the ice oceans under the moons of Jupiter, like Europa, and possibly on Titan, that large moon of Saturn, which has an atmosphere. It's a very, very different atmosphere than the kind of atmosphere we have on Earth. It's not somewhere that we would find very possible to live. But that's kind of why it's exciting to look for signs of life, because it could have been different in the past in one of these places, or life could be different, could have evolved to survive in very different environments. Every place that we look on Earth that we think is inhospitable, could never support life, we have found organisms that survive in those places without sunlight, places without air, the deep sea vents and driest deserts. Everywhere we look on Earth, we find something that can survive. So people are very excited to possibly find evidence of past or present life somewhere in the solar system, but it has not happened yet. So stay tuned.
Thank you. And I believe, Janine, you mentioned that Venus is a place we wouldn't want to go to. Could you expand on that a little bit?
Yeah, absolutely. So Venus has a really, really, really thick atmosphere. It's so thick that if you were standing on the surface of the planet, it's like being under a mile of the ocean. So if you can think about, like, if you're swimming in the pool and you swim down to the bottom of the deep end, and how much different that feels on your head and makes your ears pop and that kind of thing. So people going there under a mile of ocean, bad. I like to say people pancakes would probably be what would happen. It's also really, really, really hot. So as I mentioned, Venus has a very thick atmosphere, and that means it's really good at trapping heat. We call it the runaway greenhouse effect. So if you hear about the greenhouse effect here on Earth and how that we have global climate change happening as there's more things in our atmosphere that are making our atmosphere thicker, and we're heating up. If we look at Venus, which is our sister planet, which is pretty much the same size as us, but it's closer to the sun, very, very bad things. It's very, very hot. It's the hottest planet in our solar system, I think. If either of you know what the high temperature is on Venus, I don't know off the top of my head, but we have sent, when we first looked at Venus as people on the planet Earth, and we're like, ooh, it's so beautiful. It must have these lush forests and jungles, and we should go there and it'll be amazing, all the aliens. And so if you look at some of, like, in the 60s, some of the art of Venus and what we thought it was like, and then we started sending missions there, and so did at the time the Soviets. And I think the longest any of them has lasted is like an hour. The heat is so great, the pressure is so great that, like, we have like maybe a couple images of the surface where we're like, oh yes, we did something. It also rains sulfuric acid, so that's not a great place to be.
Temperatures are close to 900 degrees, just to cap off that amazing explanation.
Yeah, I think it is the hottest planet as a whole planet. I think there are certain spots on Mercury that, because they happen to line up with its closest point to the sun a lot, I think there's like individual spots on Mercury that are hotter. But Venus, yeah, hottest planet.
Yeah, Mercury doesn't have a good blanket of atmosphere to trap all that heat. So
All right, thank you. Well, speaking of, traveling into space and such, we have another question here asking, why did NASA spend millions of dollars developing a pen that would work in space when a pencil could be just as good?
I like this story because it cracks me up, because it's like, oh, America spent all of this time trying to develop this solution, and then the Soviets just brought pencils. There's a good reason that NASA didn't want to use pencils. It's because pencils have graphite in them. Graphite is conductive. If you're up in space where you're falling all of the time and you don't have gravity as you're used to, where everything stays on a surface, is all floating around. Now you do pencil shavings and there's little bits of graphite floating around everywhere. And you have, circuits, which are really important to making all of these things run. And they could short circuit because of the graphite. So that's one of the reasons that NASA did end up spending all of that money developing it. But also, I think it wasn't actually developed by NASA. I think it was an external contractor, and it was kind of a challenge they put out, but maybe someone else can correct me on that if that's wrong.
You just
No,
taught
I
me
didn't know
something.
that story. Yeah.
It's a good one. Go research that. I'm pretty sure
Yeah.
though that and now we have this really cool technology that's been used in other things and can write underwater, and so.
And we can write upside down in bed.
Right? Without gravity, you need a special pen to push things down. All right, thank you. I think this might be our last question, but we have a question about Jupiter, and that Jupiter has storms. What has been the biggest storm on Jupiter?
You probably know it pretty well. There's this giant feature on Jupiter called the Great Red Spot. I might as well bring up a picture of it. Just let me try to find it. Here, we'll go backwards in this thing. Whee! All right, there's the Great Red Spot on Jupiter. This thing can be seen through a telescope, even just a simple backyard telescope that some of you might have at home. As long as the red spot is actually facing us at the time that you're looking at Jupiter. But this is just a really enormous and energetic kind of swirling of gases and clouds, and it almost acts as a tornado that kind of dips into the inner layers of gas in Jupiter, and it pulls up more of that red colored gases that are kind of deeper within the planet. So that's why the red spot looks redder than the rest of the gases around it. I'm sure there's more to add about that if any of you want to chime in.
I think it's 3 Earths across, or it was at one point, and now it's shrinking. Happens with friction, right? Over time, things slow down, but it's been fueled for so long because Jupiter spins really, really, really fast, and so and it's not a rigid body. So the parts on some parts of it have to go much faster than the other parts, and that's how you end up getting all of these bands. It's all fluid dynamics. So if you're interested in it, check out some physics of fluid dynamics.
And the entire planet is covered in a ton of storms. So even these kind of smaller white spots that you see speckling the entire surface, those are all smaller hurricanes that are happening on Jupiter. And just for a fun fact, this black dot here is actually the shadow of one of Jupiter's moons. So if you were standing inside of that black dot, you would experience a solar eclipse.
That seems like a pretty fun fact to end on. So thank you so much for coming today. I'll ask you all to wave goodbye.
Thanks, everyone.
All right, thanks, everyone.
Bye.
Thank you so much. I know we do still have some unanswered questions, but we are all out of time for today. So thank you all so much for being here and asking such great questions. We hope to see you again very soon. If you'd like to check out more programs, please visit us on social media, or you can go to mos.org/mosathome. And if you've enjoyed today's presentation, please visit the website on screen to support MOS at Home. Thank you, everyone. Enjoy the rest of your day, and we hope to see you next time.